Okay. There are some things you need to know about a tree diagram. I know that you did them in middle school, but we need to define a few things. Shows a sample space. Okay, so shows a sample space. Now let's pause. What is sample space? This is a vocab word from previously in the chapter. You didn't like it. It's annoying. What's a sample space? It's a list of all possible outcomes. So if there's like, guys, there's a lot of possibilities. There's a lot of different outcomes. We made the sample space of rolling 2 dice, and there was 36 possible outcomes. So we listed them all out. Okay. Shows a sample space of a random process involving multiple stages. So I want you to think of it like something happens, then something else happens, then something else happens, then something else happens, something like that. Okay. Okay, this is one of the most important things about a tree diagram. The first branches are regular probabilities. So when you create a tree diagram in this, what you want to do is hunt in the problem for a regular probability. What do I mean by regular? I mean just like one event. All branches after that are conditional probabilities. And I'm going to give you a hint of what those will look like. It will say given or known or if. Those are the 3 words that are going to hint to you that that's not the first branches. Those are going to come off of the other branches. So given, known, or if means that it's conditional. And this little bit, this last part, we did last Friday, where we made that partial tree diagram and we multiplied down the branches to get the probability. So you set it up and then you multiplied down the branches. This one is not a hard one for our first one. Okay, I want you guys to look at it in your groups for a couple seconds. Figure out which one of these statements is a regular probability. Does anyone have an idea of which one is a regular probability? Yeah, which one? Yep. Okay, the original statement. Okay, and you can tell. What? Mhm. Yep, yep, okay. Great, you did it. That's it. Jake's got it. We can go home. Okay. So snooze, no snooze. So Shannon hits the snooze on her alarm 60% of school days, 0.60. And then what you need to use is called complements. Complements is everything else. So this has to be 0.40. Okay, if she hits the snooze, that's a conditional probability because it has if in it. If she hits the snooze, there is a 70% chance she makes it to school on time. So we have on time, late, 0.70. And the complement of 0.70 is 0.30. Does that make sense so far? Okay, if she doesn't hit the snooze and gets right up, there's a 90% chance she is on time. And the complement of 90% is 10%. And this is almost done. This is all set up. Yep, so now I need to get my answers. We're going to use what's called the general multiplication rule, which we learned Friday, to multiply down the branches. So 0.6 and show it on one just so you can see where it came from. So this one would be 6 times 3 is 18. This one's 4 times 9 is 36. This one's 4 times 1 is 4. And then at the end, if I were you, if I was taking the test, I would just add them up, make sure that they equal 100% to make sure that I did it correctly. Any questions about setting this tree diagram up? So the most important thing is that location of the regular probability. That is going to be the thing that anchors your whole tree diagram and gets you started. And then it will, the conditional ones will make sense coming off of that. Yep. How'd you know? That's how you knew? Yeah, it's definitely an FRQ. But it's funny. Does that help? I wrote it this morning. It's Halloween themed. No, no jump scares. Just comedy. That's I can't really do horror. I'm not a. Oh no, I bumped it. That's why I shouldn't use tape and I should use glue stick. Where is it on my body? Though is the question. There's a blue flare pen on me somewhere. I'll be on your forearm. It's right there. Okay, go ahead and set these guys up. So as you can tell from the FRQ, it's going to ask you to create the tree diagram, then it's going to ask you questions based off of that. Nope, just wait for me. Just write them down. No worries. Okay. What's the probability that she hits the snooze and this is and is late? So you're gonna go down the snooze, down the late, 0.60 times 0.30, 0.18. Snooze and late, literally just one of the branches, no big deal. Okay, now probability of late. I have to add together the two where she was late. Okay, next one. Probability that she snoozed given late. Okay, we're gonna use the formula for this. So probability of snooze and late. Whoops, can't write. I didn't have my tea. Over probability of late. And you might think to yourself, Mrs. Talbot, did you set up the previous two questions just so that we could plug them in? Indeedly doodly, I did. Okay, now I want to say something real quick. This is a note. If you had not done these two before, but we did these two before, we just plugged them in and got that. That's fine. This is what you would have done if you hadn't done these two before. So 0.18 is this, 0.18 plus 0.04 is this. Do not, under any circumstances, cross this out. This is not equal to 1 over 0.04. Don't do that. Do not do that. Don't do that. No. Just go to the calculator. Okay, listening. If you already have the tree diagram, that really shows us your work. To be honest with you, if you had this up here, you wouldn't need to write this either. You could just write this. I would love it on this problem if you showed the addition of those two so I could see where you got those two branches from. Because on this, if you got this wrong, I could give you partial credit for like having the wrong things in the wrong branches. Does that make sense? But I don't need this either, technically. It's just, anyway. You sure? You're good? Okay, now last one, snooze or late. We have to be really careful here. Snooze or late. So going back up here, did she hit the snooze or was she late here? Either or. She hit the snooze. Okay. Here. Yep. Here. Here. Add those three together. Does it feel to you like you're adding the three boxes of the two-way table together? And there's a bunch of ways to do this problem. You could just do 1 minus this one also. 1 minus 0.36 is 0.64. All right. Now, challenge. Now, in your groups, by yourselves, create a two-way table for this situation using what you have above. It might be a little bit spicy. You can do it. Talk it through. Snooze is such a fun word to hear people say. No. Was it created in the year 2000 or after?
Yeah.
Oh, probably haven't listened to it then. Definitely not then. No, I'm good. Okay, there's your first hint. You could put those on the side, by the way. I don't care if they're on the top or the side. Okay, there's your first hint. You good so far?
Yeah, this is like I'm watching.
That's 8. That's 8.
This will be an 8.
Yeah.
But I actually never
There it is. How'd we do? Now, I think I did it a harder way, really. All you needed to do, honestly, was take the 4 ends of the branches and figure out which box it was. So, if you looked at the snooze late branch, just put that over there. And then, yeah, no snooze late branch, that box anyway. And then add up the totals. I did it backwards, but
I did the same way.
yeah, I read it off the word problem. Either way, that is hard once you get to the late part. Then I had to like retreat back up into my work and find the 0.22. So. Any questions about that little spicy bit of your day? It wasn't spicy? Okay. I'm overreacting. A little bit spicy?
If I did it right, I don't know.
Yeah.
2x2 squares.
What do you mean?
It's really bad.
See how these lines are on the edge? Even the squares in my front.
Oh, I think when I wrote this problem, I must have been angry about driving to work. I'm getting the feeling that it was red a lot. Okay. They invited me yesterday. Yeah, that's good. There's like more questions about this below it, but that's it. What? Okay. Nothing happening. It just reminds me that I think some of those fountains in my backyard. I love that sound. Okay. Wait, not yet. No. All right. Sounds good. I will wait and make more tea. Yeah. Yeah. But these are not conditional probabilities. These are independent. Which means that, I mean, yeah. So, which means that they don't have anything to do with each other. I just, I didn't write it yet. I do have to tell you that the last MCQ on the test, I already weighed that one, and it is almost exactly like the last question that is asked in the notes here. So we can't gloss over it. It's its own little special thing. Just so you know. But these problems are easy. These are they're harder to write down than they are to actually do. So we need to be very careful though, and actually think about whether or not these events are independent. So, Jake, spins of a roulette wheel, are those independent? They're independent. Okay. And so that means that if I'm drive up to a traffic light and I declare that driving up to a traffic light the probability of it being red, yellow, or green is independent every day. We could assume that, right? I really don't feel like there's a guy sitting like at the traffic light department watching my car pull up and like making it turn red immediately before I get there.
It feels like that.
I think I might have had that feeling when I wrote this problem. But anyway, okay, so the condition is actually longer to write than the formula we use. So if events A and B are independent, okay, we'll pause there. Probability of A and B is the probability of A times the probability of B. What it means is if things are independent, you can just multiply them. So what's the probability of flipping a heads on a coin and rolling a 4 on a dice?
0.5 times 0.3.
Okay, let's do it in fractions. How about 1/2 times 1/6? So 1/12. Does that make sense? So
Yeah.
those two things are independent. So you could just multiply them. This is not to be confused with the tree diagram. Those things are not independent because they're conditional. But we can sort of assume that every time I drive up to a traffic light, it's a new event. So what's the probability that the light is green on Monday and red on Tuesday? So I'm going to say probability green, then red. I feel like that describes the situation the best. So green today, red tomorrow is what we're asking. And so we want the probability of green times the probability of red, and red is what? You guys know where the 0.55 came from?
You add the green and the yellow, and then sort of whatever, 1 minus that.
Okay, what's the vocab word for 1 minus that?
Sample space. Sample space.
Complement. Thank you. Woo. Okay, this is the end. Yeah. I think this is how I must have been feeling when I wrote the problem. And here's the really weird part.
Yeah, it's just that 7 times.
Well,
Or 5
No, but
times.
she didn't go to school on weekdays.
5 times. How do you know that?
Because why would she?
Get some raisins?
If she's great at home, you get credit. Also because she. Let me get.
Whoa,
to the 5th power is scary.
Yeah, I'm seeing this last. And you got to get the ribbon. I've seen this last year.
That's not real. It's just the power rule of being funny.
I don't know. Like, you gotta be used at some point.
Oh, wow.
So
Wow.
I'm just saying, like, I think that's the definition of being used.
Okay. Are you guys okay with the first two? So I have green, then red. So green, then red. And then I have red, then red, then red, then red, then red. But I'm too lazy to write that out. So I did to the 5th power. Okay. Now those two are easy. This is where we need to focus because this at least one
Yeah, I don't like that word.
is that last MCQ on the test. So we need to go really slow. Okay, there's 3 steps. There's 3 steps. Step 1 is find the probability of it being not red. So the probability of it being not red is 1 minus 0.55, which is 0.45. Complement. That's the word for that is complement. Okay, everybody good so far? Okay. Then we're going to find the probability that it's not red 5 times. Okay. Okay, so okay, do you guys want me to draw you a list? Okay, so I could have, oh, I forgot my 0. Okay, so this is all of my options here, right? And so I drive up to you're picturing me driving up to the light, right? And I could have 0 reds or 1 red for the week or 2 reds for the week or 3 reds for the week or 4 reds for the week or 5 reds for the week. Okay, so what I did was I found all of these added together. Probability of 1 red plus the probability of 2 reds plus the probability of 3 reds plus the probability of 4 reds plus the probability of 5 reds. Okay, the probability of 1 red is 0.55 times 0.45 times 0.45 times 0.45 times 0.45. So like 1 red, not red, not red, not red, not red. Okay, this one would be 1 red, 1 red, not red, not red, not red. This one would be 1 red, 1 red, 1 red, not red, not red. Okay, instead of doing all that, I just found the probability of it not being red at all and then subtracted from 1 to get everything else. Yes. Sure. There's definitely some things that could make this not independent, but we're just going to pretend it's independent for math purposes. Or you could just solve it like this here with the subtraction and the times and stuff, and then just put the answer, and then we would be done. You cannot assume independence, but you can answer why it would be independent. Like every time she drives up to the light is not going to affect the next time she drives up to the light. So let me go over this one more time. There are a lot of possibilities for at least 1 red. I could have gotten 1 red, or 2 reds, or 3 reds, or 4 reds, or 5 reds. The probability of 1 red would be red times not red times not red times not red times not red, plus red times not red times not red times not red. That's a lot of work. What I'm saying is find the probability of not having red at all and then subtracting from 1 to get everything else.
Yeah, I get that.
So this is the probability of no reds. And then I subtracted from 1, because that would give me 1 or 2 or 3 or 4 or 5. That's why I did it.
Is the one like 100% chance of getting?
Yes, yes, it is, yes.
So you're subtracting the 100% chance of getting it minus 4.51.
Okay, so I think that's it. I think that's it.
Read the joke. I'm like.
Oh, yeah. The joke is good. I looked at it. I previewed the joke. Hold on. Okay. We used a tree diagram, blah, blah, multiplication rule. Okay. Okay, it's a Christmas tree diagram. And the guy said, it's a Christmas tree with a heap of presents underneath. And then the lady said, we're not inviting you home next year. Because he drew a tree diagram for Christmas.
I see it. I like that.
Tree diagram. Okay, don't do that at home though. You won't get invited back.
No, Bryce, you shouldn't say my address.